Okay. Anytime you're working with radicals, okay, you need to make sure that you write your radicals in simplest form. And simplest form means no radical in the denominator. It means no common factors between the index and the power. Okay, so what this one means, and this is one that's a little less likely, but if you had something like x to the sixth, and you take the square root of that, okay, what is the unwritten index for this? Square root is?
1.
No.
0.
No.
Keep guessing.
2.
2. Okay, so the unwritten index is 2. Remember, to undo a square, you square root, right? So a square is a power of 2. So we're undoing that. Okay, this does not fit this second condition, which is it has a common factor of 2, between 2, the index of 2, and the power of 6. Because if we rewrote this in the rational power form, x to the 6th all to the 1 over 2, what does that simplify to? X to the 3rd. Okay, and so you can simplify that form. So make sure that when you write things that there are no common factors between the index and power. And this brings up the next rule, which is the index has to be smaller than the power. So when you look at this, okay, the 5 index and the power of 5 mean it's not in simplest form. You have to reduce that. So if we separate this radical, we apply the fifth root to both the numerator and the denominator individually. Okay, what do you think the fifth root of x to the 5th is going to equal? Just x, right? Because again, if we rewrite this, x to the 5th to the 1 over index of 5, we get x to the 5/5, or just x to the 1st. Okay. And then we look at this denominator, the 5th root of y cubed. Okay. Now, here's where you guys aren't going to have to do too much of this by hand for me, but if you are ever in a class where you have to do this again, if you have to do this by hand, I want you to have just been able to have seen it before. Okay. In order for us to get rid of, again, it doesn't fit this first rule, no radical in the denominator. So kind of like what we did here, if we can get the power and the index to be exactly the same, we can simplify and remove that radical, right? What would we have to multiply this by, this power, this y to the 3rd, in order that the new power would be equal to the index? So we have 3 of them already. We need a total of 5. How many more do we need? 2. So if we were to multiply the top and bottom by the same number, which is just a product of 1, anything times 1 is still the same thing, right? So multiplying by 1 is an identity property. It doesn't change the value at all. What we could do is multiply this. We get x times the 5th root of y squared. And then across the bottom, when we multiply y cubed times y squared, we get the 5th root of y to the 5th. And what's now going to happen when the index and the power are the same? You can just simplify it to the 1. So we wind up with our answer of x times the 5th root of y squared all over just what was inside that base, y. Okay. Now, again, let's see if we can do this with the calculators. Okay, so if we take our entire quantity, put it inside of parentheses, so x to the 5th divided by y to the 3rd, close off the parentheses, and we want to apply this to what power? What power represents 5th root? 1 over 5. And so now you get this answer of x over y to the 3/5. Okay. Now, is this in simplified form? No. Okay. If you were to enter this in your calculator, you can enter it exactly as it appears. Okay, but what do you notice happens here? It simplifies it as 6 times the square root of x to the 7th y cubed. Okay. We talked about one of the rules for simplifying a radical is that no power inside a radical can be greater than the index. So what's the index in a square root? 2. So is 7 greater than 2? Is 3 greater than 2? Yeah, so it did not simplify that for you. Okay. What do you think would happen if we put expand out front? Do you think that's going to make a difference? No. Okay, so what you'll need to be able to do here is to solve these by hand. Okay? And it's very easy. I'm only going to, the rules are pretty easy. I'm not going to give you a whole bunch of specifics and things to complicate this like I do in some other classes. I'm just going to give you the basics on this. Okay? When you look at this, you have to pay attention to the index. So in a square root, the index is an unwritten 2. Okay, so you're looking for perfect squares. So are there any perfect square factors you can remove from 36? Yeah, that comes out as a 6. That's what your calculator shows. Okay, and the way that I approach this is I look at each individual base separately. So I'm going to take my numeric base first. 36 is 6 squared. So the 2 and the 2 cancel. The base of 6 comes out. Okay, are there any numerical values left inside of our radical after we simplify 36? No, just the 1, right? So we leave, there's no other numerical value that remains in the radical. Let's go to our next base of x. Okay. Since 7 is greater than 2, what you need to do in order to pull your x's out is you need to find how many groups of 2 go into 7. What's the closest? 3, right? Because the closest number that's less than 7, that's a multiple of 2, is 6. And so to get to 6, you have to multiply 2 by 3. So that tells you how many groups of x's can come out. You have 3 groups of 2 that you can remove. So that comes out as an x cubed. When you remove 3 groups of 2, how many x's are left inside? Just 1, right? You remove 6 of them, 3 groups of 2. That leaves 1, so you have to leave an x on the inside. Okay, and then what about the y cubed? How many groups of 2 can you remove? 1, so that comes out as y to the first, but don't write a power of 1. It's unwritten. So y comes out, and when you remove 1 group of 2, how many y's will be left inside the radical? 1. So this winds up being your answer. And so if you were entering this online, this is the way that you would enter that.